Okay, as I said earlier, we have one more topic from section 2.7. Okay, and I will cover that remaining part from an example. And that example, okay, let me find out here. Yes, thank you. So in section 2.7, we are trying to find the possible outliers, okay? And we will use box plot and a z-score to find the possible outlier. So you already did the box plot, right? So if you find any measurement in between lower inner fence, or like if you find any measurement in between inner fence and outer fence, those are the possible outlier. But if you have any measurement, okay, away from outer fence, they are the outlier, okay? So that is one method, using box plot. Next method is using z-score, okay? So here, let's do this example here. So the data on post-mortem intervals of 22 human brain specimens has a mean and standard deviation of, okay, so we have mean as a 7.3. So mean of a PMI value is 7.3 and standard deviation is 3.13. Now, what symbol do we use here for the mean and standard deviation? Are these the mean and standard deviation of a population or a sample? Sample, right? So we have a sample of 22 human brain. So this is the mean of a sample. So our X bar is 7.3. and S is the standard deviation of a sample is 3.13. We are asked to find the z-score for the PMI value of 3.5. Okay, so 3.5 is one measurement out of 22 measurement. We are asked to find the z-score for this measurement. And the formula to find z-score is G is X minus X bar divided by S. Okay, so our X is the measurement for which we are finding the z-score, and that X is 3.5 minus X bar is 7.3 divided by standard deviation is 3.13. Now I want you to help me here. So 3.5 minus 7.3 divided by 3.13 is negative 1.21. So we have 1.21 as a z-score for this measurement 3.5. Now, from this z-score, can you tell me where do we find this, like where this measurement is located from mean? So our mean is 7.3, okay, and our measurement is 3.5. We have the z-score for the 3.5 as a negative 1.21. So where is this measurement whose z-score is negative 1.21 located from the mean? Do we find on the left of mean or on the right? Okay, so from here what we can make a conclusion. So every measurement that has a z-score negative is on the left of mean, okay? And the measurement whose z-score is positive, it is on the right of the mean. Okay, now do we consider this 3.5 as an outlier or not? Okay, so to be an outlier, possible outlier, if the z-score is greater than positive 3 or z-score is less than negative 3, we take those measurement as a possible outlier. But what is the z-score for 3.5? It is negative 1.21. Now, do we take 3.5 as a possible outlier? No. Okay. So this is the condition, okay, that help us to find the possible outlier. You find the z-score for a measurement. If the z-score is greater than positive 3, okay, or z-score is less than negative 3, then those measurements are possible outliers. Okay, So this is about section 2.7. Okay, and we are done with section 2.7. Now, let me go to, okay, does anyone have any question for number 10? Okay. So number 8, so from here you will have a 3 question, okay? So there will be a 3 question, 1 question related to stem leaf diagram, dot plot and box plot. Now, the first type of question is that you might be asked to draw the diagram for these 3. That's the one type. The next type is that you might be given a dot plot or you might be given a stem and leaf diagram. You have to answer a question based on that diagram given to you. Okay, or you might be given a box plot and you have to answer the question based on that box plot. Okay, so these are the 2 type of question that you will see from number 8, and there are 3 questions. Okay, out of those 3 questions, 2 question is you will be drawing a stem leaf diagram, dot plot or a box plot, and 1 question is you will answer the question based on the diagram given to you. Okay, like for example, does anyone have a stem and leaf diagram for this data? Okay, let me borrow. So the question, like, okay, so here we have a, okay, so here, so for this measurement we have a stem and leaf, right? Now the question is that, so what is the measurement that occurs most in this data set? You won't have the access of data set, okay? Keep in mind, you won't have the access of data set. You will have only this stem and leaf, okay? From this stem and leaf, you have to answer a question. For example, what is the measurement that occurs most frequently? Which measurement occurs most frequently? 10 and 12. Okay, that's the answer. Okay, so you will be able to, once you have the idea of these 3 different type of the diagram, you will be able to answer the question. Okay, so in the similar way, you might be given a dot plot. Okay, and you will be asked to answer question based on that dot plot. Okay, now let me go back and start from number 1. So in number 1, suppose every student in a class is surveyed and it is reported that 75% of the class plans to take another math class. Is this an example of descriptive or inferential statistics? Okay, now, so descriptive statistic. So in descriptive statistics, it describes the data set, okay? The inferential statistic, it helps us to make a generalization. It helps us to make a decision or estimation, okay? Now here, so there is a class, okay, every student, so there is a class, okay, the class is surveyed, and from that survey, what we find, 75% of the class plans to take another math class. Is it inferential or descriptive? Okay, now let's go to number 2 before we finalize. Now in number 2, suppose it's the same question. Every student in a class is surveyed. It is found that 75% of the class plans to take another math class. It is reported that 75% of all students at this school plan to take another math class. Is this example of descriptive or inferential statistics? Now, do you see a difference here? So which one is inferential, which one is descriptive? Okay, do you have a reason for that? Why? So you say 1 is descriptive and 2 is inferential, right? And why you think that?
Because the 2, they're saying from the sample from the class that the whole school, 75% was taking math.
Okay, so what is your reason?
I thought number 2 was saying that we know for a fact that the whole school is the population, and we know for a fact that 75. The first one doesn't say anything about the whole population, so
it does not
would be the sample.
Okay, so number 1 is only about the sample. Does it tell us anything about the population?
So
In the number 1, does it tell us anything about population? So population is the student at the school, okay? So now in number 1, so it does not tell us anything about the population. But in number 2, so found 75% of the class planning to take another class, okay, and they use this sample result to generalize the result for all students at the school. So number 2 is the inferential and number 1 is descriptive statistics, okay? Yes, go ahead.
How do you know, okay, because the reason I had it flipped, because I don't, the second question, I didn't read it as that the 75 from the sample is now implying it. Whereas the first one, I was saying that the 75 of the sample was implying for the population.
It's saying that they took the 75 from the sample and reported it as a population
Okay,
statistic.
so it's just the wording of the question.
Yeah.
Okay.
Okay, so the very easiest way is that if the sample has been used to make some generalize population or to make an estimation of the population, then that is the inferential. If there is no generalization, estimation, or decision, then that is the descriptive. So descriptive tells about the data. It does not tell anything about the population. Okay. In the inferential, there is always the sample is always used to make a generalization of the population. Okay. So the next type here, the next number 3. Suppose you are given a data set that classifies each sample unit into one of 4 categories. So we have 4 categories. You plan to create a computer database consisting of this data, and you decide to code the data as, so we have 1 for A, 2 for B, 3 for C, and 4 for D. Are the data consisting of the classification A, B, C, D qualitative or quantitative? What type of data set is this? So we have a data set that classifies each sample unit into 4 categories, A, B, C, D. Okay, but they decide to code these categories as 1 for A, 2 for B, 3 for C, and 4 for D. Now, what are these A, B, C, D? Are these quantitative or qualitative data set? Qualitative data set, okay? So ABCD does not occur in number naturally, but they assign a number for these categories, okay, to code. So this is qualitative data set. After the data are input as 1, 2, 3, 4, are they qualitative or now if you have a data set that has 1, 2, 3, 4, now will this 1, 2, 3, 4 as a qualitative or quantitative?
In this situation, it's qualitative, because it's just assigning a number to it. So instead of A, it's 1.
Okay, so this is going to be confusing. So after the data are input as 1, 2, 3, 4, are they qualitative or quantitative? Okay, so if you are given this data set 1, 2, 3, 4 only, what will be 1, 2, 3, 4? Quantitative, right? But we know our 1 is A, 2 is B, 3 is C, and 4 is D. So it will be qualitative. Now, but okay, now it does have a after the data are input as. What will be the best option here? I will go with the majority of you. Do you want to use a qualitative or quantitative? Qualitative. Okay. Qualitative. But so here from this example, you'll have a question and you'll be asked to classify the variable, whether it's a qualitative or quantitative. Okay, so you must have an idea of what are the qualitative and quantitative data. Okay, you'll be asked to classify like here. Okay, and let me tell you, do not expect exactly same question on your exam. Okay, so I want you to learn or get the ideas here. So don't expect exactly same question. Okay, the next here, so number 4, the National Science Foundation, NSF, promotes girls' participation in formal science, technology, engineering, and mathematics STEM programs. What has been the impact of these informal STEM experiences? This was the question of interest in a study, okay? So the impact of STEM experience. A sample of 151 young women who recently participated in a STEM program were recruited to complete an online survey. Of these, only 28% felt that participation in the STEAM program increased their interest in science. Now, we need to identify the population of interest to the researcher. Now, what is the population unit? Young women who recently participated in a STEM program. Okay, so young women who participated in a STEM program is the population.
That says it's the sample.
I'm sorry?
So wouldn't it be both? The 150 women is the sample, but the young women in STEM are?
Yeah, all young women who participated in a STEM program is the population, but 151 is the sample.
Okay.
Okay, so out of all women who participated in a STEM, that is, all women are the population, but out of all of them, 151 is the sample. Okay, so we are interested in women who recently participated in a STEM program. Okay. Who recently participated in STEAM. Okay, so out of all of them, we only have 151 in our sample, and that is our sample. So 151 women who participated in STEAM are the sample. Okay. Use the information in the study to make an inference about the relevant population. Now, from the study, we find 28% felt that participation in the STEAM program increased their interest. Now, how can we use this result to generalize for all young women who participated in STEAM? How can we write that? So from the 151 sample, 28% they felt it increased the interest in science. Now, how can we use this to our population? How can we write this how can we write this result for population?
28% of women who participate in STEM programs feel like it increases their interest in science.
That's right. So 28% of the young women who participated in a STEAM program felt it increased their interest in science. Okay. So instead of sample, you're going to use the population. That's the difference. So 28%. So 28% felt that. So 28% of all. Okay. So you're going to include here. So 28% of all young women who recently participated in STEAM felt that participation increased their interest in science. Okay. Okay. So let's do up to 4. Okay. And the remaining we will do in our next class.